In question number 18, if a variable horizontal force F is applied on 2 kg block, then choose the correct options. So if I apply a variable horizontal force on 2 kg block, then the situation is this. This is 2 kg block. Let the variable force F is applied in this direction. So if I check the option A, 4 kg block will remain at rest for all possible values of F. So we know that the maximum friction force between 2 kg and 4 kg block will act in this direction, and that is 3 Newton. So when 3 Newton is acting, then in order to oppose the motion of 4 kg block with respect to ground, 3 Newton will act in this direction. But the maximum friction which is possible, F3, is 7 Newton. So 4 kg block will remain at rest. So option A is correct. In option B, maximum possible acceleration of 1 kg block will be 2 meter per second square for all values of F. So in case of 1 kg block, the maximum friction which is possible in this direction is 2 Newton depending on the value of F. Suppose it reaches to this value. At this value, the acceleration maximum possible of 1 kg block is 2 divided by 1, so that is 2 meter per second square. So option B is also correct. In option C, maximum possible value of frictional force between 4 kg block and ground will be 7 Newton. That is wrong. That is 3 Newton in this case. So option C is wrong. In option D, maximum possible value of frictional force between 1 kg and 2 kg block will be 2 Newton. So this is true, which is the maximum frictional force F1 possible depending on the value of F. So option D is also correct. So the correct answer for question number 18 are option A, B and D. Let's move to the second paragraph containing question number 19 and 20. In this paragraph, consider the circuit shown in diagram. Value of R is 1 ohm and L is 1 Henry. Initially, switch S1 is closed at t equal to 0, while S2 remains open. After a long time, when current in each branch becomes constant, switch S2 is closed and simultaneously S1 is opened. On the basis of above information, answer the following questions. If I1 and I2 is the current through inductor L and 4L respectively, then the correct options for the value of I1 and I2 we have to find out. So if I redraw this diagram at t equal to 0, when switch S1 is closed and S2 is open, in that situation, this will be like this. This 4L, this 2L are in parallel, so their equivalent is 4 by 3 Henry. This is 2R. Value of R is 1, so it is 2 ohm. This is 1 ohm. This is also 1 ohm. And if I draw the equivalent of this part, so if I draw the equivalent battery about these 2 points, then its EMF is 1 volt, where positive is here, and the equivalent resistance comes out to be 2 ohm. So this is the circuit at t equal to 0 when S1 is closed and S2 is open. So at this instant, if I write the current I through the battery, then this I can be written as at any time t I max into 1 minus e raised to the power minus R by L into t. The maximum current is possible when the inductor coil is in a steady state. At that moment, this inductor coil will behave like a conducting wire, and at that moment the current through this 2 ohm branch will be 0. So the value of I max comes out to be potential is 1 divided by total resistance in the path is 4 ohm. So this is 1 by 4 ampere, and in order to calculate the value of the R equivalent about the inductor, in order to get this battery is shorted, and about these 2 points the value of R equivalent comes out to be 4 by 3, that is 4 into 2 divided by 4 plus 2. So the value of R equivalent and L equivalent are same, so the R by L get cancelled out. So if I write this at any time t, this will be 1 by 4 into 1 minus e raised to the power minus t. Now, if this current is reaches to this junction, then it's get divided. Let's in this direction I1 goes, and in this direction I2 goes. So we can say that L1 into I1 is equal to L2 into I2. So the equivalent of this branch is 2L into I1, and it is 4L into I2. So from here I1 is equal to 2 times of I2, and we know that I1 plus I2 is this. So from here the value of I1 is 2 by 3 of I, and the value of I2 is 1 by 3 of I. So we will see that option A and C are correct. So the correct answer for question number 19 are option A and C. Let's move to question number 20. In question number 20, after the switch S2 is closed and S1 is opened, if H1 and H2 are the heat loss in resistor R and each of 2R resistance respectively, then choose the correct options. So in the case when switch S2 is closed and S1 is open, at that moment whatever is the energy stored in this inductor, that would get dissipated through this resistors. So if I find out the total energy stored initially at t equal to 0 in the steady state, that can be written as half Li square. L is 4 by 3 and I is I maximum, that is 1 by 4 whole square. So it comes out to be 1 by 16. So if I solve this, it comes out to be 1 by 24 joule. Now the equivalent of these two resistance is R. So this stored energy is dissipated in this resistance R as well as in this resistance R. So we can say that the heat dissipated H1 through resistance R is half of U. So it comes out to be 1 by 48. And now heat dissipated in 2R is again 1 by 2 of 1 by 48. So it comes out to be 1 by 96. So option A and option D are the correct answer. So the correct answer for question number 20 are option A and D. By this, I wish you all the best for your preparation. Have a good luck. Thank you.